Hello, everybody, and welcome to the sixth grade topic 7 review. I thought I would make a little video to help those of you that want to make sure you're doing this correctly before taking your next test in sixth grade. So, I'm going to do the review and show you how to do it. You can fast forward through any of the questions that you think you already know, but I'm going to go through each one and probably have to do more than one video. Okay, so here, let's start. Let's start with number 1. Caroline is making a triangular flag, which I drew a picture of here, with a base of 10 inches and a perpendicular distance from the base of the flag to its vertex is 8 inches. What is the area of the flag? Okay, so the base and the perpendicular distance really is the height. So that base is going to be this guy right here. So we're going to label that. This is 10, it says. That's our base. Perpendicular distance. Perpendicular means it's going to make a 90-degree angle from here to this vertex, means this corner here. Okay, so this is our 90-degree angle. And it says that that is 8 inches. Now, in order to find the area of the flag, you would need to know what the formula for area of a triangle is. So the formula for the area of a triangle, in case you missed it, is the base times the height divided by 2. Now, base and height must make a 90-degree angle. If they don't, you have the wrong measurements. So in this case, we have both the measurements we need. So we would do our base 10 times our height of 8. And then we have to divide that by 2. And 10 times 8, it would be 80. Divided by 2 would give us 40. And it is inches squared because area is really all of this inside of there. It's a two-dimensional measurement. Okay, cool. Number 1, pretty easy peasy. Number 2 is a little bit more challenging. One, because right away you have X's in there, so ooh, watch out. But it's not as bad once you know what's going on. So it says 2 figures are arranged as shown. Select the expressions that can be used to find the area of the figure shaded light gray. So first and foremost, these copies, if you have a copy, it looks like this is the light gray, but looking at what the actual book had, this part right here, this bigger L-shaped part, is really the light gray part. So that's where we need to find the area, is this L shape. So one way you can do that is by finding the area of the whole shape, right? This whole square, which most of us know would be to multiply the length and the width. So 9 times 9. But then we got to take out this part, right? So this part we don't want. So even though we don't know the number, we know that to get that square, we would have to do x times x, no matter what that number would be. So, and we want to subtract that out of there. We don't need that part. Okay. Then you're looking at these choices and you're like, but I don't see that choice on there. So something we have to remember is that 9 times 9 is the same as 9 squared. 9 squared and 9 times 9 are the same thing. And that would be the same for x times x. So the first one that we get is this one, this 9 squared minus x squared. Now, the other one that we have to find is a little more challenging kind of to think about. So the other way that you could figure out the area of this is by kind of ignoring this space right here and breaking this part up into 2 rectangles or squares. So let's pretend that we are going to break up this part, boop, 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 into these 2 rectangles. Again, we're going to kind of ignore that part because we don't want the area of that. All right, let's look at the taller rectangle. So the length times the width. So our length here is 9. That's fine. Times, what would be our width? What's going to be from here to here? And this is where it's kind of challenging. So if you look from here to here, that length is x right here, right? See it? X, that's x. which means that, right, since this is 9, this other side is really going to be also x. And some of you are like, it's 4.5. Well, 4.5 isn't one of those choices in here. So this one's going to be 9 times x. Or 9, I'm sorry, not x. This side's x. This would be 9 minus x. Right? Because 9 minus this part, it leaves us here. So this part right here is 9 minus x. So 9 times 9 minus x. Now, when you do it like this, you have to put parentheses because that's a whole value, okay? Now, you still have to find this other little part. And so it looks like we know that this side is x. Well, what's from here to here? Well, again, we got to use this side, right? And so this whole side is 9. We know from here to here is x. So from here to here would be 9 minus whatever that number is. It looks like it's even. You cannot assume that it's even and say it's 4.5 because sometimes the drawings are off. So this one would be x, this guy, times 9 minus x again. And we got to put it in parentheses. Okay, so there is a difference here between the two. And then we would want to add those together because you need the space of this one and the space of this one. So if we add those up, right, if we were to add that, you can't actually add the numbers, but you can look for the formula. Oh, look, 9 times 9 minus x, ooh, that's that one, plus x times 9 minus x, that's that one. So this would be your second one. All right, let's keep going. Number 3. Number 3 is talking about a playground. The playground has the shape of a trapezoid, which they gave you a picture of. The shortest side of the playground and its width have the same dimension. Okay, so let's stop there. So the shortest side of the playground and its width. So here's the shortest side of the playground right here. What is its width is the question. Well, a lot of us are like, okay, the width always goes left to right. It doesn't always go left to right. This is the shortest side of the playground. In this case, right, if I turn this, it's still with our idea of width. This could be the width. Sorry, bell ringing. Okay, so the width in this case, if we turn it, is actually 6. So the shortest side, this guy right here, is the same as the width. So we know this is 6 yards right here as well. Write the numbers in the boxes to show the missing dimensions. Okay, so we did that there. And then we have to figure out the long side of the playground. What would it be for the trapezoid? So, oops, sorry, excuse me. So the long side, if this from here to here is 6, it tells you from here to here is 1, right? So there's 6, 7. What is going to be from here to here? Another 1. So our total would be 6 plus 1 plus another 1. So that side's going to be 8 yards. Okay, now the question below it says, what is the area, the whole area of this trapezoid-shaped playground? So the area for a trapezoid, we have to break this up, right? So the main big shape in here is actually a square, right? So this square is 6 times 6. We got to start with that. 6 times 6, that equals 36 for that square. And then we have to add on those little triangles. So the base, again, we talked about that. It's base times height divided by 2, right? So our base here would be 1, that's our base, times our height of 6. Then we got to remember, since it's a triangle divide by 2, triangle divide by 2. 1 times 6 is 6, divided by 2 should give us 3 for that one. And then we have an identical one over here. So we can know that it's also 3, but I'm going to do the work. It's base of 1 times height of 6 divided by 2. That's also 3. And then what we would do to get the total area is add those up. So 36 plus 3 plus 3 more is going to give us a total of 42. But that is not our whole answer. Don't forget your units. We're finding an area, remember? So that is a 2-dimensional. So that's going to be yards squared would be our final answer in the box. Okay, so let's stop the video here and we will continue. If you need the next section, you can watch the next video.